Hello friends, so today we are going to do an awesome LeetCode problem that has been asked in bunch of different IT companies. So without any delay, let's get started. So the problem is insert, delete, get random, big O of 1. And if we want to understand the problem statement, basically we need to implement a randomized set class where we need to implement these three methods. That is, first one is insert, second one is delete, and third one is get random. And we need to make sure that we implement these methods in big O of 1 time. Now you can see that this is a LeetCode medium problem and also a very well-liked problem, but in my opinion, this should have been an easy problem. Also, if you want, you can read this whole description. If not, let me just give you an explanation that what this problem is asking us to do. Basically, we need to create some sort of data structure where we can keep track of three items. First one is add, second one is remove, and third one is get random method. Okay, so let's try to understand each of the method one by one. Now for these two methods, we don't need to return any values. We just need to return true or false because we need to return a boolean value, and this would be defined based on the value is present inside the existing set or not. So let's assume that currently this is an empty set and we are being asked that, okay, just add value number 5. So if we have to add value number 5, we can add value number 5. And because 5 was already not present inside the existing set, we need to return true in this case. Next, we might be asked to add value number 7. So once again for 7, we will add it and return true. Once again, we might being asked to add value number 9. So once again, we will repeat the same process and the answer is also going to be true. But now let's say for an example, once again, we are being asked to add value number 5 once again. But because 5 is already present in this case, we can't add the value to our existing set, but we can simply say that for this 5, because it was already present, we did not add it inside the set, we need to return false. So this is the logic for the add method. Second logic for the remove method is also very similar. That let's assume that for this example, let's add one more value 11. Okay. And now for remove, we are being asked to remove value number 9. So first we need to check that whether 9 is present inside our data structure or not. Yeah, so 9 is present. If 9 is present, we need to remove 9. So let's get rid of 9. And currently we only have three values, 5, 7 and 11. And because 9 was present and we removed it, once again we need to return true for this one. Once again, let's assume that we are being asked to remove value number 17. Now 17 is not present inside our existing data set. So in this case, we will return false because we did not remove any values from our data set. Okay. And for the get random method, this is just very simple. Whatever the values are currently present inside our set or data, we simply need to pick any random value. So if we are being asked to get random, we can return value number 7. Next time we might return value number 11. Next time we might return 7 again. Next time we might return 5. Once again we might return 5. Any number of values, it is going to be randomly picked and we have no control over it. Now for all of these three cases, simply we are just implementing the same method, and also the logic is going to be that we need to complete all of this in big O of 1 time. Okay, now the thing is, for this get random, actually it is very beneficial for us to use any existing method that is present for any single language like C, Java or Python. All of these language, they have their own way where they actually store, or where you can actually pick a randomized value from the existing set. So this is very beneficial to us, but there are few problems in our cases and we need to do things slightly bit differently in order to achieve the solution. Now first, let's try to take this problem one by one iteratively, and the moment you understood that we need to solve this problem in big O of 1 time, you must have understood that we need to do one or two things. We can either use hash map or hash set in order to solve this problem. So if we have to solve this problem, actually if we only needed to do like add and remove method, we should be able to complete this using hash set or hash map. Both of this would fruition the same result, and we would be able to complete this problem in big O of 1 time using any of the hashing data structure. So let's try to see that in example. Let's assume that we initiate a hash set, and now currently we try to add the values. So let's assume that we add value number 5. Okay, so 5 was not present inside the hash set. We can check this in big O of 1 time. Because it was not present, we add value number 5 to hash set and we can simply return true. Once again, we need to add value number 6. So once again, we will repeat the same process, add 6 and return true. Same way we need to add value number 7. So once again we will return add 7 and return true. Okay, this works in big of one time add method, no issues. This is a very simple thing. Once again, if we have to implement the same logic for the remove method, let's say that we need to remove value number 6. So we can simply return true and say that okay, 6 has been removed, and that's it. Yeah, we can say that because 6 was present, we removed it from the hash set, so it is no longer there, and we return true. Once again, we need to remove value number 8. We can check in big O of one time that whether 8 is present inside our hash set or not. Because it is not present, we need to return false in this case. So both of these logic works exactly fine, no issues with this. But when we need to do get random method, we cannot implement get random method in this scenario, because typically get random, for that we need to say that okay, give me, if I use like predefined method of get random from any single language, that method typically works like that. If there are values between 1 to 100, give me any random value, and it can return any value between like 7 or 51 or 55, something like that. But the thing is, in our case, we only need to find the random values between value number 5 and value number 7. Now one logical method comes to our ways that we take count of all the values, put them in some sort of list, and then in the list we only keep the values that are already over here. So we are simply going to create a list of size 2 where we are going to have values 5 and 7, and then we can say that give me a random value amongst between 0 and 1 0 and 1 index values, and based on the index value, so let's say for the first random we get index value 1, so we return value number 7. Let me broaden up the horizon. So let's assume that there are few more values, okay, 9 and 11. So between 0 to 4 I need to return some values. Okay, so in the 0 to 4 I need to return some values, and now in the first 0 to 3, basically 4 values. So in the first time it says that the value is 2. So if value is 2, we need to find the value at index location number 2, that is value number 9. So we can return 9. Next time, if with the value is 3, once we can return value number 11. So on and so forth. Now the thing is, for get random, in order to use get random, we need some sort of indexed data structure where we store all the remaining values, and then we select a random index value, and whichever value is located on that index location, we need to return that value. So we already know that we already took care of this add and remove method using the hash set. Okay, but the thing is, in order for us to implement this get random method, we need to keep track of a list that contains all the values that are currently present inside our hash set, and we need to know that at what index location which value is present, because when we try to add a value, we need to add it at any particular index location, or we need to keep track of that index location. Why? Because when we have to remove that value, we can remove it from the hashing data structure, but we also need to remove it from our array list. And if we don't know the index, if we have to search one by one, then this becomes big of an operation. So this is the complexity. But once you know that you will have to use two data structure, this becomes very easy and very simple to do. So let's try to solve this problem, and we will try to go through the add, remove and get random methods. Now you all know that how does get random work. Once we have this list with all the data structure, and list only contains the data that is currently present inside our hashing data structure, it can be hash set or hash map, anyone, then it is very easy to implement the get random method. Okay, so this we already know, but tricky part is managing this list with this hashing function at the same time. So in this approach, hash set would not be a good choice. Actually, we will have to use a hash map in this problem. So let's try to solve the same thing using hash map, because we need to keep track of the index location. This is the important part. So now once again, let's assume that this is currently our hash map. In the hash map, we know it's a key value based data structure. So as part of the key, we are actually going to store the value or the incoming item that comes in with our method add. Okay, or add or remove. These comes in with an integer value. So whichever the integer value that it comes in with, this is going to be stored in the key portion of our hash map. And as part of its value, we are also going to have a subsequent array list. and inside this array list it is also going to have index values. So let me mark some index values over here, 0 1 2 3. Okay, and as part of its value we are going to store the index numbers so that we can do add and remove operations quite easily. Now let's say that let's see the logic for the add operation. Let's assume that I need to add value number 1. Okay, so I can add value number 1 over here because 1 was not present. First I will check whether 1 is present or not. Because 1 was not present, I add value number 1 inside our hash map. Okay, all of this operations happens in big O of one time. At the same time I add 1 in the very last position of the array list that we have created. Now currently this array list is empty, so very last position is also going to be index value number 0. So I'm going to store 1 over here, and whatever the index value is, that is going to be the size of the array list, and that index value I'm going to store as the value for our hash map. So this is going to be value number 0. Same way if I need to add value number 2, once again the logic is going to be same, 2 2, and because this index location is 1, so I'm going to store 1 as the value. Let's add value number 5, so 5, and index value is 2, and let's add value number 7, so 7, index value is 3, and this is our array list so far. Okay, and for all of these operations I'm returning true because these values were not present. Now let's say that I do one more operation, add value number 7 once again. So in this case, because 7 is already present, which I can check in big O of one time, so because of that I can simply return false, saying that 7 is already present, so I cannot add 7 inside our data set that we have stored. Now let's go back to the remove function. For the remove function, the logic is actually quite simple, but we need to do some additional steps. Why? Because we need to make sure that this list only contain the data that are currently present inside the hash set, and any data that is out of order, we need to fix the order because we might need to remove some element from the middle as well. So what is going to be the logic? Let's assume that we are being asked to remove value number 5. So what we can do is first go to the value number 5. We know that 5 is present, which means we will have to remove this. So the answer is going to be true. That is for sure. But what is going to be the logic for removal? First, we will check that, okay, for 5, where it is stored inside our array list. So it is stored at the index location 2. So this value we will have to remove. But if we remove this value, then we might end up in a position where the values would be 1, 2, then this is going to be a null value, and then the last one is going to be value number 7. Okay, so now the problem is that the value number null is no longer there, and in this case if we have to implement our getRandom method, if we randomly select value number 2, then we might end up returning null, which means we will only need to keep the valid values, no longer the null values. So for that, what we are going to do is, let's assume that we get rid of this one, and then this is a null value. We realize that we need to remove value number 5 from this position too. So one simple logic is that we are going to swap value number 5 with whatever the last element is inside our hash inside our array list. So let me remove this one. So we are going to have a scenario where this is value number 7, this is value number 5, and then we can simply get rid of the last element inside the array list. So we will not have 5 over here, and we will also not have value number 5 over here, and we are simply going to have value number 1, 2 and 7 inside our array list, and we are also going to have 1, 2 and 7 inside our hash map, which means our add and remove function will work exactly fine. And when we get to a level of getRandom, we can simply select the random value of amongst any one of these 3 index values. So currently the index values are going to be, give me a random value between 0, 1 and 2 index values, and it can randomly pick any values, and this can work for even if we have 100 values, the same logic is going to be there. So this is the approach. Now the time complexity, obviously for add remove, it works in big O of one time because we are using hash map, and for the getRandom, because we are using the pre-built method that operates in big O of one time, and we are only searching for the index value, and fetching a value from the index value of the data structure works in big O of one time, then also it is the same thing. So this is the whole solution of this problem, and it's a very interesting problem once you understand the trick. Okay, so now let's see that what is going to be the coding logic for this problem. Okay, so now let's see the code for insert delete get random. So first we are going to initialize our hash map, and we are also going to initialize an array list. We are also going to initialize a variable called rand to store the random values, and we are going to initialize our public randomize set class. Now first thing we need to implement is the insert method. So for that we need to implement a boolean method insert, where we are inserting a value. The first thing we are going to do is check whether this value is part of the key of our hash map or not. If it is part of the key, we can simply return the false. If it is not part of the key, we need to add the value to our hash map. For that we are adding the value as the key, and the size of current array list is going to be the index value, because we are always adding the value to the very end of the list, and we can also add the value to the existing list as well, and we can simply return true. Now let's see the logic for the remove operation. So first we check that whether the value is present inside the key or not. If it is present, if it is not present, we can simply return false, because there is nothing for us to remove. If it is not present, and if the value is present, then we need to first get the index value for that particular position, and we need to get the last element inside the existing list, because we need to swap the values. Okay, then we are going to swap the elements inside the existing set that is about to be removed, and we are going to update the value inside our hash map. Plus we are going to simply remove the last element inside the array list and also inside the hash map, and in the end we are going to return true, that we return the values. And then last method is the get random method, where we are going to simply run the get random method inside our existing list, and in order to find the next randomized item, we are simply going to look for the all the available index values of our list. And this is the whole logic. So now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs much faster than most of the other solutions. So that is pretty good. And this is the whole solution.